All right, the first thing we're going to do in section 13.3 is talk about evaluating angles if you are given a point x comma y. Okay, that's what this entire thing is talking about right here. But what we're going to do first, actually, to introduce this, is just look at the example that it says. It says evaluate the six trig functions of theta, given that the point negative 4 comma 3 is on its terminal side. What quadrant is that in? Second, right? Second quadrant, negative, positive. Now, before learning what we're about to learn, so actually right now, with what you have, I would expect that most of you would draw a quick sketch. So don't do this yet. Most of you would draw a quick sketch, find out where negative 4, 3 is, okay? There's negative 4, 3, and then use a triangle in order to answer this question. But here's what you need to know then. The angle you're actually going to use is that angle right there. And notice where I dropped that perpendicular. When you draw this right triangle, you have to go to the x-axis. Remember how I said the x-axis is the important axis. You cannot draw this thing this way. Okay? You need to go to the x-axis. So if I draw this as my right triangle, what does that make this length right there? 3. What does that make this length right here? 4, right? And if you want to put negative 4, because you can do that. And then this guy is 5 because it's a Pythagorean triple, right? And now you would use that little red theta, and you would do something like this. Well, the sine of theta is opposite over hypotenuse, so 3/5, right? And that is going to be the answer to the sine in our problem. We're just going to do it in a little bit different way. I'm not saying that this way is wrong, but this way uses right triangles outright. And what we're going to do is kind of use a trick using how we know right triangles are related to the relation between x, y, and that hypotenuse right there. So here we go. If you are given a point x comma y, oh, by the way, I'll go back here. If you didn't know that that was a Pythagorean triple, how would you find it? If you didn't know that that 5 was, how would you find it? Pythagorean theorem, right? So in other words, you would take a squared plus b squared set equal to c squared, right? But here, a squared and b squared are actually x and y. So you would say x squared plus y squared equals, instead of calling it c squared, we call it r squared. So in other words, r is going to equal, if I take the square root of that whole thing, we'll actually have a spot on here to write this. R equals the square root of x squared plus y squared. That's how you find r. And once you have r, you can use x, y, and r to find these six trig functions. Here's how you find them. Sine is going to be y over r. Before I go any further, is that what ended up happening in our problem right here? Y is 3, r was 5. Look at sine is 3/5, right? Just so you see, it's not magic. It actually works. And we came up with it before getting these little formulas. Okay, so sine is y over r. What do you think cosine is then? X over r. Tangent, if you use the idea of sine over cosine, is y over x. And then we just flip them to get these next three, r over y, r over x, and x over y. So let's use these ideas in order to answer this question right here. Now, I still would actually not mind if you guys just draw a quick sketch. And it doesn't have to be crazy, but just kind of get your head into the problem and say, okay, negative 4, 3 is right here. Because then maybe you could just remind yourself that you're in quadrant 2, which is negative, positive. And actually, as soon as I do that, I'm going to come down here and put those negatives in the correct spot. Now, a quick thing about this. When I put these like lines in there, you can use them as fraction bars if you want to. You can use them as blanks if you want to. Sometimes I don't even put them there. I don't care how you use them. I'm going to use them as blanks here. And I know that since I'm in the second quadrant, cosine is negative, which makes tangent negative. And these two are negative as well. Their reciprocals are negative. Only cosine is negative, not sine. And when these two are different, then you know that tangent is negative. All right, so let's go ahead and find our values then. Just put some fraction bars in here. We said that sine is y over r. Well, we haven't written this yet, but r is 5. I'm just going to take a quick second to write 16 plus 9 in here, just to show us where we're getting that 5 from. In the case that it's not a Pythagorean triple, you'll actually have to do it. Sometimes you won't be able to simplify that either. It'll have a radical in it, so you're going to have to do some rationalizing in your answers down below. But we were pretty nice here in this one here. So we have y, which is 3, over r, which is 5. And then cosine is y over r. And I already took care of the negative, so you don't need to write the negative up with the 4. And then tangent is negative 3/4. Numerator over numerator, sine over cosine. And then we just flip them to get the reciprocal functions. Negative 5/4, negative 4/3. Questions on that? Yes?
So for the r equals the square root of x and x squared plus squared, there's no like plus or minus.
Correct, because we're considering r to be a distance, so it's always going to be positive.
Okay.
Good? All right. We're going to do another example like that in a second. We're going to try something with the quadrantal angles here. So this is something that you did on your unit circle yesterday, but we're going to break it down a little bit here. What I like it right here is quadrantal angles. Okay? And the blank up above is meant to be unit circle. Basically, it's saying what you did yesterday. That if you have a circle with a radius of 1, it's called the unit circle, or it can help us in evaluating trig functions. All right? And remember, on a unit circle, we have cosine, comma, sine as we go around the unit circle. So what we're going to put here are just those quadrantal angles. I'm going to focus in just on this thing and talk about the quadrantal angles. So the first one is at 0 radians. I'm going to stick with radians here. What's the point there on the unit circle? 1, 0, right? Let's go up to the next one. Pi over 2. So right there. What's that point on the unit circle? 0, 1. And then we have pi, whose point is negative 1, 0. And then finally we have 3 pi over 2. And that point in the unit circle is 0, negative 1. Just like you could evaluate the 6 trig functions of any of the angles within the quadrants, you can evaluate the 6 trig functions with the quadrantal angles using those points. What we're going to do is just look at the angle pi. It says let theta be pi and find all 6 trig functions of theta. So in other words, find all 6 trig functions of pi. So I'm just going to put on here, we're talking only about pi in this problem. So I'm just going to write that's pi, and the point is negative 1, comma 0. So think about what you just wrote down. You just wrote down cosine, comma sine. So the cosine of pi is negative 1. Anybody got a calculator? Type in the cosine of, and I don't know what your calculator is in. If it's in radians, type in cosine of pi. If it's in degrees, type in cosine of what? 180. Either way, if you hit enter, you should get negative 1. That's a quick way to find out what you are in. Type in cosine of pi and see what you get. What'd you get? Did you get negative 1? Okay, if you didn't, you've got to switch what mode you're in. The sine of pi is 0. We okay at this so far? Okay, so if you're in radians, make sure you're putting in pi when you're just kind of checking this in your calculator. But here's the thing. We won't be using our calculator for this. You're going to be using the unit circle for this, or what you know about the unit circle. Here's where things get interesting, though. Ready? Tangent. Without using your calculator, is sine over cosine, right? So tangent really is 0 over 1, which is 0. How about cosecant? Cosecant is the reciprocal of which function? 1 over the sine, right? So I'm just going to write it's 1 over sine, which is 1 over 0. It's undefined. This is undefined. The cosecant of pi is undefined. Anytime you put 0 in the denominator, it's undefined. Or anytime you try to flip 0, it's undefined. Watch, you could actually do this on your calculator by saying, I don't know if you guys knew this, but your calculator has this little inverse button right there, little reciprocal button. If you type in 0 and then take the inverse of 0 and hit enter, it'll actually tell you divide by 0 here. Can't do it. Okay? It'd be like finding the sine of 0. I don't know what I'm in here though. Not 0, excuse me. The sine of pi or 180. Let me find out what I'm in. Actually, I want to be in radians. You ain't cool if you're not in radians. Here we go. So we got the sine of pi, but I'm going to take the inverse of that. It's going to say it's an error. Okay. By the way, that's different than the little blue trig functions that are up there with the inverses. Those are different. Those are a totally different thing. We're going to talk about those in a few sections. This is taking the inverse of the value, not the inverse of the function. Okay. How about secant? Secant is 1 over cosine, and cosine is -1. So 1 over -1 is just what? -1. When you flip 1, you get 1. When you flip -1, you get -1. Cotangent, what do you think? Spencer, what do you think? Tangent was 0, so what do you think about cotangent? Nope. What happened when we were trying to flip 0 before?
Oh,
Undefined. Probably should not use your name since I'm recording this, and now generations to come will know that that was Spencer that answered that incorrectly. It's a good thing I didn't say it was Spencer Tennis and you use your last name like that. Okay. The next two examples are repeat examples of what we just did. All right. Try those. Example 1 is kind of like what we just did, and example 2 is like the one that we did before. Okay. I'll give you kind of a startup on both problems, kind of a push in the right direction with both those problems. I'll give you a second to finish answering those. All right, so the first thing we're going to start with is the fact that this point is at 0, -1, or the point in the unit circle is 0, -1. So there's our cosine right there, and there's our sine right there. Cosine is 0, sine is -1. Because tangent is sine divided by cosine, you're taking -1 divided by 0, which is undefined. Okay, anytime cosine is 0, tangent will be undefined. So think about where cosine is 0. Cosine is 0 on both these axes right there. So tangent will always be undefined at pi over 2, 3 pi over 2, and any angles that are coterminal with those angles. Okay. Now we flip them to get the other two. Well, when you flip 1, or -1, you get -1. When you flip 0, what do you get? Undefined. The reciprocal of 0 is not defined. But if something is undefined to begin with, when we take the reciprocal of that, then it's 0. In this scenario, in dealing with trig functions. Okay? Or the other thing you could say is cotangent is cosine over sine. So you have 0 over -1. You know, if you want to make a little note to yourself, 0 over -1, which is just 0. Okay? But obviously it's quicker just to remember, oh, if tangent is undefined, cotangent is 0. All right, let's try the next one here. That's it. That's all you had to do for that one, is use your point 0, -1, and then flip them. You're good. So the next one gives the point -5, -12. That's in quadrant 3, and I just got that just from those two negatives there. So I know that sine and cosine are both negative, which means that the reciprocals are both negative. So I'm going to start setting this thing up here. And I know that they're all going to result in fractions that I can't simplify. So tangent and cotangent are positive because sine and cosine are both negative. R is, this is Pythagorean triple again. 25 plus 144 is 169, so R is going to be 13. Okay, or maybe you just remembered 5, 12, 13 is a Pythagorean triple. So R is the denominator for sine and cosine, and we flip it. It's the numerator over here. So sine's numerator is y. And that should be actually pretty easy to remember, you guys, since sine is related to y in the unit circle. So this is going to be a 12 here. This is going to be a 12. This is going to be a 12. Nope. All right, and then, set for a second, our x value of 5, or negative 5, is going to help us get cosine. It's going to be the denominator here, sine over cosine, and we're going to flip them. Put up a 12 right there. Any questions on those? You can do that. I prefer that you get used to doing that because I think it's a good connection between x, y, and cosine and sine respectively. But it can be done using a right triangle. Okay. All right. Last thing we're going to do today. This is it. This is like the tip of the mountain here. This is what everything else has been building up to it. The unit circle, the angles, the angles that we've been talking about, going back to the x-axis. Those angles going back to the x-axis, like in this picture right here, I'm talking about this angle right here. It's called the reference angle, and it's denoted by theta prime. Okay, theta prime. Given theta, theta prime is the smallest angle between the terminal side of theta. So in this case, the terminal side of theta is right there, and the x-axis. Okay? It's always that angle between the x-axis and the terminal side of the angle. Theta prime is always acute, so that means you always have to go to the closest x-axis, and it's always positive. It doesn't matter if you're going backwards or forwards to get to the x-axis, theta prime is always positive. Okay? Theta prime is called the reference angle. The reference angle is used to help find all the trig functions. Let's just practice finding a reference angle here. Example 3. Oh, actually, before I do that, this is a little blurb I took from your book here. This is like breaks it down on exactly how you would find a reference angle using a little expression. I think the best way for us to do it to start with is just using, and this is the way that we'll always do it actually, just using a sketch. So we're going to sketch whatever angle they give us. So that says 5 pi over 3, right? So thinking in terms of pi over 3, we know that this is 3 pi over 3 and that this is 6 pi over 3. Which one of those is 5 pi over 3 closer to? 6 pi over 3, right? If I went all the way around to 2 pi, that'd be 6 pi over 3. I'm short, though. How short am I? Pi over 3. Now, if you want in your head go, that's 60 degrees to help you figure out like how big to make this drawing or the angle, keep kind of the scale, you can, but keep things in terms of radians. Okay? We just said we're pi over 3 short. That's the reference angle. The reference angle is pi over 3. Guys, we've been setting you up for the reference angle idea for the last 4 days. Every time we've sketched an angle, I've always said, how far short are we of the x-axis, or how far did we go past the x-axis? Okay, or drawing it, we'd say, how far do we have to do that? Okay, and so we're always thinking about the reference angle. So the reason why we want to know the reference angle is 5 pi over 3 and pi over 3 have the same trig functions. Okay, in fact, we're going to make a little trig table here in a second, but if you remember what the trig functions are of pi over 3, 5 pi over 3 has the exact same values, except because it's in what quadrant? Fourth, cosine will be positive, sine will be negative, tangent will be negative. Otherwise, all the values are the same. Okay, let's try another one. Reference angle of negative 135. Let's figure out what negative 135 is. Well, I know if I went all the way to the x-axis, it's negative, so I'm going down. If I went all the way to the x-axis, I'd be at negative 180. I'm short of that, though. How far short? 45 degrees. That's your reference angle. Reference angle is, theta prime is 45 degrees. We can keep it in degrees since the original problem was in degrees. So if you found the tangent of negative 135, it would be 1. Because tangent's positive down there, and the tangent of 45 degrees is 1. Okay? The sine and cosine of negative 135, they're both negative square root of 2 over 2. They're both negative because we're in the third quadrant. Square root of 2 over 2 from 45 degrees. Let's do some of those in examples. Now we're going to actually evaluate some trig functions. Okay? This is basically what you did on your unit circle, but we're just asking you to do 1 instead of asking you to do like 16 of them. All right? So you got the tangent of negative 240. There's 2 things you need to find out. Where is it? What quadrant is it in? Because that'll tell you if it's positive or negative. And what's its reference angle? Because that'll tell you the value. Actually, before we do any of that, there's not a ton of room up here. I think I'm going to do it right here. Let's make a quick little trig table because we're going to need it for these 2 problems. So we're going to go pi over 6, pi over 4, pi over 3. And if you also want to put degrees 30, 45, and 60, and we're only going to do the 3 major trig functions. Okay, so I'm just going to go SCT just to say sine, cosine, tangent. All right. Does anybody remember what that one is right there? It's the easiest one. 1/2. What's its partner? Square root of 3 over 2. Those 2 are always together, sine and cosine. And when we come down to 60, what happens with them? They flip. Square root of 3 over 2, 1/2. Good. Okay. How about the sine and cosine of 45 degrees? They're both the same, right? Square root of 2 over 2. And since they're both the same, we know that the tangent value is 1. Now to get the tangent value of 30 degrees, or pi over 6, you got to go sine over cosine. Numerator over numerator would be 1 over the square root of 3, but we need to rationalize. That's going to be the square root of 3 over 3. 60 degrees is a little bit easier. Pi over 3. Pi over 3, when I put sine over cosine, I get square root of 3 over 1, which is just the square root of 3. There we go. Those are what we're going to use down below now. Now, even if they ask us for one of the other 3 trig functions, cosecant, secant, or cotangent, we can just take what we have in our table and flip it. Or if you have more time, make the whole trig table. Let's go try it here. First one says, tangent of negative 240. Draw a sketch. We always start these with a quick sketch. Doesn't have to be anything crazy. I know that negative 240 is going to go past that x-axis how far? 60 degrees, right? Because we're at negative 180 right there. I'm going to go past it by 60 degrees. That's our reference angle. Even though we're going back to the x-axis that way, it doesn't matter. The reference angle is always positive. It's always acute. So the reference angle for this problem is 60 degrees. Right away, write this. The tangent of 60 degrees from up above is the square root of 3. Right? Do you see that in your table? That's going to be part of our answer. Let's start writing our answer down below here. Tangent of the square... Tangent of negative 240 degrees equals, well, we just got the square root of 3 because the reference angle was 60 and we were taking the tangent. Now let's talk about where it is. What quadrant is that in? Quadrant 2, which is negative, positive. Which one of neither one of those is tangent. How do I get tangent from those? What would you say tangent is because we're negative, positive there? It's negative, but why? It's positive divided by negative, right? Okay, so tangent, sometimes I just put tangent below. Tangent's negative, okay? Or you can just write tangent is, something to tell you that it's negative, and then that's the other part of the answer. There's 2 parts to your answer. The positive or negative, and then what value is it? So you just evaluated that without a calculator. Your calculator would give you the exact same thing. All right, let's try the next one. Start with a sketch. By the way, I'm writing a ton of work for these because these are examples. You don't need to write all that stuff like tangent is negative, and you just need to get the right answer, to be honest with you. But I would start with a sketch. Man, 18 pi over 6 sounds kind of like a good value to know. I know that 18 pi over 6 is equal to 3 pi, right? 3 pi would be 1, 2, 1 pi, 2 pi. 3 pi would be going all the way around, but I'm short of that by how much? By pi over 6. Well, Leave it in radians though. There's no reason to go into degrees. There's our sketch. So we know what quadrant we're in. We're in quadrant 2. Again, it is negative, positive. Cosecant's reciprocal is sine, right? That means that cosecant is positive, say is greater than 0, just like sine here. Okay? So our answer is going to be positive. Now we just need our value. The cosecant, what's our reference angle? Pi over 6, right? Keep it in radians. The reference angle is pi over 6. So we need the cosecant of pi over 6. From our table, you know that sine of pi over 6 is 1/2. So that means that the cosecant, which I don't have written, is 2. If you want to say something like 1 over 1/2, you can for your notes here, but it's just 2. So we have, our answer is, I'm going to write the whole thing here, cosecant of 17 pi over 6 is equal to, we don't have to put anything for positive, but I'm just going to say that, I'm just going to put that arrow there like that to say, that's why I don't have a negative sign there, cosecant is positive. And then our answer is, I don't need a fraction bar, I just need 2. That's our answer. The answer to this whole problem is 2. If you had your calculator in radians, and you typed in cosecant of 17 pi divided by 6 and hit enter, it would simply say 2. And we got that all on our own. Okay, so this is what everything has been leading up to. These seem like big problems right now. And in the very near future, they become much smaller problems within a much more complicated problem. So we need to get good at these sorts of things. I know that sounds really exciting. You guys are all pumped to hear that, I know. Okay? But you got to get practice evaluating these things.